say squared plus b squared equals c squared? Okay, but double check me. Let's see, I want this, I've got something in mind here, so. Angle A is 45 degrees. Up. That's not good. I gotta keep the smaller one. I'm trying to be consistent with that. Okay, let's say I tell you angle B is 45, angle A is 35. Angle C you don't know yet, though some of you probably already do. And since I've given you angle A and angle B, I'm going to give you side length. A is 10 units, B is blank, C is blank. Giving you 3 pieces of information, I want you to tell me the other 3. Sam, you've done this before. Alright, so I'm going to give someone else a chance to start it. Okay? Layla, tell me what you noticed, first of all.
Angle C is 100.
Angle C is 100.
No.
Yeah, it is.
Yeah.
Double check.
Yeah.
70, 80, 180. Okay, now, here's what we can do. So that part was easy, I hope. Now what we can do is we can set up some proportions to find out the side length of B and the side length of C. Hope somebody's got the TI-83 calculator with them today.
You have to have the A in one of them.
Sam just made a great point. We know side length A. Okay? So if we know side length A and angle A, we have to use sine A over A for one of our
Or
proportions.
else you have 2 variables.
Otherwise, you'd wind up with 2 unknowns. 2 things you don't know. Who's got a choice between trying to find... Now what we're going to try and find is side length B or side length C next. Who's got a preference?
B. It's tough.
Sam has a
It's
preference.
the first one. B.
It's a toss-up. Okay. So this is going to equal the sine of B over B. Okay, now all I do is I plug in from what I know. The sine of A is the sine of 35 degrees. Length of A is 10. The sine of B is the sine of 45 degrees. Length of B is what I'm looking for. What do I usually do with proportions set up like this?
Cross multiply.
Does everyone agree with Sam?
Yeah.
Yeah.
Yeah? Okay. So this is going to be B times the sine of 35 degrees equals 10 times the sine of 45 degrees. Now this is just a number. It's going to be an ugly decimal number, but it's just going to be a number. Which means I can divide both sides by the sine of 35 degrees, and that will be the length of B. That's your answer, right? It's my answer. Trick question. Warn you in advance, it's a trick question. Can I simplify the 45 and the 35? Can I reduce that?
No.
No. No, 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 no. Luke said no because he knows I always tell him he can't reduce in fractions. A lot
And
of
you
times
said
he wants
trick
to.
question.
I know, I said
Yeah.
trick question.
And then you said hand trick question.
Alright, so who's got a calculator handy to tell me what this is?
12.32.
Pardon?
12.32.
12.32. Okay, next question.
You have to put it in degree mode, right?
If you're going to use 45 and 35, yes.
You can't do the Pythagorean theorem, can you?
No.
Because or not the Pythagorean theorem. Well, first of all,
You can't do the Pythagorean theorem since it's not a right triangle.
Yeah, but if you're doing the opposite and you're finding the angle, you couldn't plug that in because it's not exact, right?
12.32?
No, I'm talking. No, yeah, that's not exact. Is it? Like if is that
No,
what-
it's not going to be exact. Almost none of these will be exact. But you can do it that way. I mean, basically for this, you're always approximating. You only get exact answers with the... there's only 2 ways to get exact answers. With the unit circle stuff, the square root of 3 over 2, the square root of 2 over 2, or with those formulas that are on your cheat sheet, like the sum and difference formulas and the half angle formulas. And those get hideous. For now, we're approximating. So the answer is, you're correct, you can't get exact answers, but that's okay now. Okay, so now, how do we find side C?
A squared plus B squared plus C
No,
squared.
no,
That's what Sam just brought up,
That's
the
not
Pythagorean
the-
theorem.
These
Yeah.
are sides.
Did you plug in all this stuff and
Yeah, now we have to do it again.
put C?
Oh,
Oh.
doesn't matter if you use an A or an B, you have to do it.
Okay. It doesn't matter, but
Use side A because it's
Already worked.
finish that thought. What was that, Dean?
that's not the decimal.
Dean just made a great point that I was about to make. He jumped to the gun for me. You were given the exact side length of A to be 10, right? So which is probably going to get you a more accurate answer for C? If we use sine A over A, where we're given this answer of 10, or if we use sine B over B, where we figured out this approximate answer. Which one's going to work better? A. So let's go ahead and use the information we were given, and now we know that it's sine of 35 degrees over 10 equals, what was C? Sine of 100 degrees over C. Okay? So then we get C sine 35 degrees equals 10 sine 100 degrees. So C equals 10 sine 100 degrees over the sine of 35 degrees. Did I do the algebra correctly?
Yeah.
A little quickly?
Yeah.
Yeah.
All right, who's got a number for me? Amy?
17.16.
17.16. Anybody else double check that? Get the same, get different?
17.17, but I mean, it just goes to, I mean.
Let's see your rounding.
Same thing,
It
but-
ought to be the same thing you put in. Yeah, that should be 1.7. Did you get 169, Amy?
The last one also was
Yeah.
12.33, not 12.32.
Okay, yeah, we'll have a rounding review, I think, before this test.
Are you going to be that exact?
Let you know when we get to the test.
Wait, Mr. Bell.
I'll tell you what I want you to round to. Yes?
Why does it matter if we choose A instead of B because those are the only calculators? And either way, it's the same answer.
Well, we cut this off, right? This was 12.3,
It should be 3.
and like Michelle said, it should be 12.33, and it'll keep going. And it'll probably keep going on forever, because most of these answers will be irrational. Okay? So, because of that, your calculator's doing its best job of approximating. And if we stick to only going to the 100th places, you're probably right. Not now. Thank you. Try and find someone else. All right. You should get a slightly better approximation if you were given an exact number to start with. Slightly better. Honestly, for these, it won't be a big difference. But, yeah, if you have an exact answer to start with, use that one. Double check, okay? And this is something where I will be less merciful on partial credit. A was the smallest angle. B is the medium angle. C is the biggest angle. Okay? Did I get the smallest side opposite the smallest angle, the middle side opposite the middle angle, the largest side opposite the largest angle?
Yes.
Yes. Does that guarantee my answers are right?
No.
If that hadn't happened, would my answers be wrong?
Yes.
Yes. That's the Goldilocks theorem. Everybody's in the right size bed, or has the right size bowl of porridge, whichever you prefer. All right. There is one special case here. And remember in geometry, thank you. Wow, of all the words to suddenly blank on. You were told there was no SSA or ASS theorem, that you couldn't use that to prove the two triangles were congruent.
Right.
All right? We do have an SSA law of sines case, and it is deeply weird and may require some judgment on your part. Are you ready?
No.
Good. Okay.
But what do you mean?
I'm about to draw. I think this is going to be a visual.
Wait, so that was ASA?
Yeah, that was an ASA case. Okay? Now,
You do the same thing for most of the other ones, right? For each-
whatever I just erased, that I said what for law of sines you can do, but your proportions might look a little different. I'd love to have time to do an example of each, but I think I'll run out. But yeah, you do the same sort of thing. You might be filling in two sides instead of two angles. Okay, that'll take a little bit of creativity.
All right.
But here's the one I really want to make sure I get to. And I have to draw a very specific sort of triangle for this to happen. Yeah, and it's got to be oblique as well. Here's angle A. This should be angle B. That should be angle C.